Hello, in this video we're going to look at an implementation of bubble sort using Java. Now, I've written this inside a method, and so essentially what I'm going to do is I'm going to pass the array that I want to sort into this method and then sort it. What you want to make sure you're aware of is the fact that I don't have to return this array in order for the sort to remain when this method is done, and that's because arrays are reference variables. Remember that when I pass an array into a method, I'm passing a reference to where the array exists. So any modifications that are made to the parameter remain once the method is done. If you don't fully understand this concept, you might want to go back and take a look at the video that I have on reference variables and how arrays work when used in methods. So what I've done here is I've simply printed out the array. This is a shortcut to print an entire array to the screen. I've invoked the bubble sort function or method. Those words are interchangeable. And then I've printed the array again. So if I run this, you'll see that there's the array before the bubble sort. The bubble sort is executed, and that's the array after. And in fact, let's just put in here system.out.println executing bubble sort. So let's run this again. There's my array. I execute the bubble sort, and there's the sorted version. So the bubble sort consists of two loops. And to help you visualize it, let's jump back to this. So let's just pull this back to the start again. So what we see if we go through this relatively quickly is this bubble moves up through the entire array, but then the bubble has to go back to the start and do it again, and do it again, and do it again, do it again. The outside loop is actually controlling the number of times you have to pass the bubble through the entire list, because each pass is only sorting one element. So if I have 6 elements, I'm going to have to do 5 passes of that bubble. And so I'm going to set my outer loop to start at 0, and I'm going to go to passes less than a.length minus 1. What the inside loop is doing, the inside loop is actually moving the bubble. So what I do is I'm going to start my bubble I'm going to start my bubble at index 0, but I don't have to go to the end every time. So in this case, the very first pass I go through, let's just rewind this, the very first time the bubble goes through, it's going to go, I has to reach this position here, because we're always comparing the element to the right of it. Now the second pass, if I go through this again, the second pass has to reach one left. So in my implementation, what I'm going to do is I'm going to start I at 0, but I is going to be, I'm going to continue as long as I is less than a.length minus 1. So it's never going to reach the last element minus the pass that I'm on. It actually doesn't matter if I do this. This would still work. But what you're doing here is you're making an already inefficient sorting algorithm even more inefficient, because remember, each pass, the largest element is being moved to the rightmost position. So we want to put that there. This is my comparison, so this is my comparing the two elements. And if a at I is greater than a at I plus 1, that means we have to actually swap them. So this is my swapping of elements. And that's how the bubble sort works. And that's a bubble sort example inside Java. There's lots of different ways you can write this. It all is the same thing. So down here I have a second implementation where, as opposed to looking at I and I plus 1, I'm looking at j and then j minus 1. It's just a matter of how you're going to position your loop. Finally, very easy modification to make this sort, instead of from smallest to largest, we can make it sort from largest to smallest. All we have to do is just swap that inequality sign and say that if a at I is greater than a at I plus 1, we're going to swap. Pardon me. We're going to swap it the other way. If I swap that inequality sign, it sorts in the opposite direction. I'm not going to go back and modify that kind of mess up, because it's good to see that I make mistakes. You wouldn't know that this is my 12th attempt to record this. Anyways, that said, I hope this video helped. If you have any questions, please don't hesitate to ask.